get started. That's just a summary of what's going on the next week in this class. So we're going to cover functions today, applications, and mixture problems, so lots of word problems today. And then we'll finish that up on Wednesday. I'm going to hand you a review, and maybe we'll have some time to go over that review. And then next Monday, you just come in, you take your second test, and that's all we're doing on Monday. So the exam, if you follow the schedule, there's some stuff that we covered that was not on exam 1 that's going to be on this exam, specifically scientific notation and conversions. Were not on that first exam, right? Y'all remember that? Okay, so even though the schedule says that after test 1, it starts at conversions, right? But scientific notation will also be on there, so just be aware of that. And once you get the review, I think you'll have a better idea of what to expect. Okay, any questions on this? All right. So let's get into today's stuff. It's going to seem kind of weird today because we're gonna be like jumping around doing different like 3 different things, and they're going to seem sort of disconnected. So I just want you to be aware of that. I understand that these topics are going to seem a little bit like we're just all over the place. So it's just the way it is. Okay, we're going to start with functions. All right, so when it comes to the idea of a function, so pretty much from this point on, we're going to be dealing with lots of functions. We're going to be dealing with lines, parabolas, polynomials, rational functions, exponential functions, and logarithmic functions. So 6 different types of functions that we're going to be studying. And so the first thing we need to do is get an idea of what a function is. So I'm going to write the definition. It's a little weird, but let's just look at the definition. A function is a rule which assigns to each element x exactly one element y, or we will also call this f of x. So I'll get into that in a second. So this is the definition. It's not easy to read. It's weird. It's just kind of like, what? Okay. So visually, what a function does, this is the common notation we use for it, is we've got this set over here, which we call the domain of the function. And these are just numbers in here, all right? So for example, the numbers 1, 2, they can be anything, 5, -4. So those numbers are what we call the domain of the function. What the function does is it takes each one of these and it assigns to it exactly one new number. So like it's going to take the number 1 over to something. Let's say it takes the number 1 over to 2. Maybe it takes the number 2 over to 4. Maybe it takes the number 5 over to 10. Maybe it takes the number -4 over to -8. So the rule, okay, there's a rule that I'm following when I'm moving these numbers from here to here. And that rule is the function. So can y'all tell what the rule is here? I'm just doubling it, right? All I'm doing is multiplying the number by 2. So this is a specific example of a function. This right here, the numbers that come out, this is called the range of the function. Okay, so the domain, another way to look at the domain is this is the input. Okay, this is what's going in. And then this is the output. So I like to think of a function like a car wash. You take a car and you send it through the car wash, comes out clean car, right? So the rule is that the machine is going to clean the car, right? So there are some situations that look a little different than this, and we have to ask ourselves whether or not it truly is a function or not. So, oh, I forgot one thing. So arbitrarily, if I have some x here, this takes this x over to some y, right? That's what this is saying. It assigns to each element x exactly one element y. So for every x that goes in, there's some y that comes out. So take a look at this right here. This is a new example. I'm going to draw, let's just do 3 numbers here. How about I do 8, 5, and -4. All right, so there, that goes to -4, and this one goes to -4. So think about this. Is this a function or not? Yes. You're saying yes, I'm hearing some no's. So the rule is, to be a function, it says we have to have a rule, right, that assigns to each element x, okay, so these are our x's, this is a domain. It assigns to each of these exactly one thing over there. So all you have to ask yourself is, do each of these numbers go to just one place over here? So does 1 go to one place? It goes to 8, okay. Does 2 go to one place? Yeah, it goes to -4, right? Does 3 go to one place? Yes, it goes to -4. The fact that 2 and 3 go to the same place doesn't violate the definition. It doesn't say it can't go to the same number. It just says it has to go to one place, right? One place and one place only. Does that make sense? So this is still a function. All right, well, that's a really nice check mark. Okay. All right, let me give you another example. Okay, here's an example. How about we'll go 1, 2, 3. Let's just go 4, 5, 6. So what if I tell you that 1 goes to 4, 2 goes to 5, 2 also goes to 6, and 3 goes to 4? Okay, now is that a function? No. This one fails to be a function. Why does this one fail to be a function? Which one though? 2. So 1 goes to 4. That's okay, right? 3 goes to 4. That's okay. 2 goes to 2 different places. And when we say here exactly 1, we're saying that it can only go to one place. This is like putting one car in a car wash and getting 2 cars out the other side, right? That'd be a really nice car wash, but yes, that's not allowed. That fails to be a function, all right? So what we want to study now, or what we're going to study, are functions and functions only. That's what we want to look at, all right? Things that behave like that, things that do not behave like this, all right? So that's just the general idea of what a function is, all right? Any questions on that? One more. Let me ask you if this is a function. Okay, 1, 2, 3. Let's go 4, 5, 6. How about 1 goes to 5, 3 goes to 4. That's it. This one's a little tricky. So do you think that that's a function? What's causing the problem in your mind? 2 doesn't go anywhere, right? 2 doesn't go anywhere. So the things that do go and get sent somewhere, do they go to exactly one place? Yes. Okay, so that's not a problem. The question is, what about the 2? So the fact that the 2 doesn't go anywhere does not mean this is not a function. What it means is that this 2 right here is not in the domain of the function. So the best way I can explain that is, I was talking about this car wash, right? So you go and you take your little, Ford Fiesta, you send it through your car wash, it gets cleaned, right? You take your big old F-350 dually truck, send it through the car wash, maybe, I don't know. Can they handle a dually? Maybe they can, I don't know. Then you go and you pull up with an 18-wheeler, right? You can't send that through the car wash. That number 2 is the 18-wheeler. This function does not know how to handle that. So that 2 is just not in the domain. But the things that can go through are treated the way they're supposed to be treated. Does that make sense? Okay, so when we draw this picture, I said that this set right here is the domain. The domain is only the numbers that can go through, all right? So in this case, what would the domain of this function be? Just 1 and just 3, okay? That would be the domain. 2 would not be in the domain. All right, with that said, let's get to some notation. So notation here. For functions, obviously. All right, so let's take a look at something here that you've actually seen already. Right there. This is what? What are we looking at right there? That's a linear equation in 2 variables. Does everyone agree with that? This is a linear equation in 2 variables. I could have walked in here today and given you a quiz and asked you to graph that, right? And everyone would have done it perfectly. Right? Okay. So this we've studied. Now, the question I have now is this a function? So the idea here is this. If somebody gives you a number, right? If somebody gives you an input, can you determine an output? All right? So right now, if I were to give you x, if I said, hey everyone, x is 2, could you tell me what y is? If I say, go replace that with 2, could you then go figure out what x is? Oh, sorry, I did it the other way around, sorry. If I tell you that x is 2 and that becomes a 6, could you then go solve for y? Right? So if I say right now that my x's are going to be, let's say, 2, where would that 2 be sent? What would our output, what would our y be? So let's just do it real quick. If this x is 2, that's 6 plus y equals 10. So then y would equal to 4, right? Because you would have to subtract 6 on both sides, right? So if you plug in 2 for x, it's going to spit out and force your y to be 4. Agreed? All right. Let's do another one. How about negative 5? If I plug negative 5 in for x, can you figure out what the y would have to be? Well, let's see. If we plug in negative 5, 3 times negative 5 plus y equals 10, then that's negative 15 plus y equals 10. Add 15 to both sides, right? And you would get 25. So again, if I provide you an x, looks like you can provide a y, right? So for every x that gets plugged in, looks like there's a y output, right? And I could keep doing this all day long. Now, there's some machine that's doing this, right? There's a machine that's taking 2 to 4 and negative 5 to 25. And what we'd like to do right now is figure out what that machine is. So the way we do it is we go to this original equation. Does anyone know what I'm about to do? I'm going to solve for y. Okay? Solve that equation for y right now. So how would you solve that for y? Just move the 3x to the other side, right? Subtract 3x on both sides, so you get y equals, let's just write it 10 take away 3x. So I took this equation, I subtracted 3x, I subtracted 3x, and now I have that, right? Okay, this is our machine. Look at it. If I plug 2 in here, right? 3 times 2 is what? 6. 10 take away 6? 4. Okay, plug in negative 5. Negative 3 times negative 5 is going to give you 15. 10 plus 15 gives you 25, right? So you see that this is like a very nice representation of the actual machine. And the key to it was that I isolated y. I solved for y. So if anyone gave me, if someone gave me another linear equation in 2 variables, if I solved for y, I would have the machine. So since this is our machine, we use a special notation to let everyone know, hey, look, you're looking at a function, all right? And the notation we use is that we replace this y with this notation, f, and then in parentheses x, and then we just write the machine down. So this right here is our new notation, that right there. All right? The way you say that, okay, the way that you would actually like verbally say that is you would say f of x, okay, f of x. Now, this machine that goes from here to here, the name of that machine, the name of it is that letter right there. F is the name of the machine, or the name of the function. A lot of people will say that the name of this function is f of x, but it's not, it's f. So I can give you another example of some notation that I could use. Let's say I wrote this down. Let's say I said something like this. Okay? So I just told you that this is a machine, right? This is a function. What's the name of this function? G. We'd say that g of x, right? And this is like the y was before. It says, look, if you hand me an x, right, give me an x, I will provide you an output. And all I have to do is plug that x into here. So let's say I wanted to say something like, hey, let's plug 5 into this, all right? Then the way I'd write that is this. I'd write g parenthesis 5 like that. And that's telling everyone, hey, everyone, plug 5 into that function and see what comes out. So all you do is replace that x with 5. And that would be what, 15? So this is a different function than this one, right? Here's another one. I could do so this is another function, right? How do you know it's a function? Because I used the notation. This is the notation we use for functions. We do something here. Here it was g, and then parentheses x. Here, what's the name of this function? Cost. So this would be the cost function. And again, you know it's a function because I used this notation as opposed to just putting y equals something. All right? Okay. Now, what we're going to do next, if everyone's okay with the notation, is now what we're going to do is we're going to step away from being stuck. These are all linear, right? These were all linear equations. Now we're going to start looking at functions just in general. Like, let's get away from linear. Just let's try something else. So how about something like this? I'm going to go back to f because we really like to use f a lot. So what if I give you this function here? What if I give you that? Okay, so again, how do you know that this is a function? Because of the notation, right? I've told you, I'm telling you right now that for each input, there's exactly one output, right? So I'm telling you that, you don't have to assume that. I mean, I'm sorry, I said that completely wrong. Because I'm using this notation, you can assume that every input goes to exactly one place, all right? If I did not put this here and I put y equals this, then you could not assume that. And it might not be a function. You might have one thing going in, two things coming out. Okay, so this function, what we want to be able to do is evaluate it. In other words, plug in some different values of x. So let's evaluate this function. Okay, the first problem I want us to do, we'll start off really basic. So this means, I guess we'll just mix these sticks up again. I don't think I got through everyone last time. I'll ask again, is this anybody's? No? No? What the hell? I thought after class last time someone came up to me and told me, hey, someone left this here. Oh, was it the calculator? It's not this then. Oh, it was the calculator. That's what it was. Okay. Does anybody want a, no? Kind of gross. All right, Rodrigo. There you are, okay. Do you know what you're supposed to do with this? Can you explain it, like in words, what you're going to do when you see this? Replace x with 1 in that expression, right? Okay, so most of y'all have done this or are comfortable with this, but we have to be a little careful. Maybe not with this example, but with the next one. So I'm going to replace the x with 1. So I'm going to write this, what, 1 squared minus 4. How do I do that, Rodrigo? 4 and then 1? Yeah, because if I just write 1, it'll look like 41. So I need to somehow let you know I'm multiplying. So I'm going to do that, 4 times 1, and then minus 5. Now, Rodrigo, is there anything that you would do differently as far as the way I wrote that down? No? You're okay with that? Anyone have any recommendations on a different way to write that? Because I think there's a better way. Yes? Put the 1 in parentheses. Now, it doesn't seem like that makes a big deal right now, but it makes a huge deal in a minute, all right? See, what this x squared means is that you're going to square whatever x is, right? Okay, so 1 squared is just 1, so it's not that big of a deal here in this problem. But on the next one, you'll see why you can get in trouble with that. Okay, so we square 1, we get 1. Negative 4 times 1 is negative 4, and then minus 5. And then this is just subtraction, so we just move from left to right. I think you can all do that. That's negative 10. Okay, good. I was hoping to see some looks like that. I'm just seeing if y'all are paying attention or not. This is negative, positive, what is it? Negative 8, okay. Negative 8. All right, so for this particular function, right, that we're looking at, it sends the number 1. You don't need to write this, but what we know about it is that it sends the number 1 over to the number 8, right? And we also know that 1 doesn't go to any other place, right? Like 1 will not go to some other number. And that's because I use this notation. You can be assured that's never going to happen. All right, here comes the next one. F of negative 4. Andrea? Okay. So I want you to just tell me what I'm supposed to do. Again, when you see that, what am I supposed to do here? Replace all the x's with negative 4. So go ahead and just tell me what you want me to write. I'll put the equals. You go from here.
So parentheses, 4 squared.
Okay.
Minus 4, parentheses,
Okay.
minus 5.
Minus 5. Perfect. That is a really nice way of writing out this expression. Now, do we see why the parentheses are important? Let's look at this. Let's look at this expression right here, negative 4 squared. We talked about this very early in the class, the difference between those two. What's the answer on the left side? Negative 16. What's the answer on the right side? Positive 16. Right? This means square 4, so you get 16, and then make it negative. This means negative 4 times negative 4. So when you multiply two negatives together, you get a positive. So these are very different expressions. And so if you don't put this in parentheses, you might actually make that a negative 16 that's not. All right? So be careful with that. Because I guarantee I like to give this on the test because I want to make sure you understand this. So this will become, what, 16? You want to keep going? 16, and then plus 16 again. Negative and negative become positive, and then minus 5, and that's 100, right? No, what is it? 27, okay. All right, so it takes the number negative 4, maps it over to the number 27, right? And we could just keep doing this all day long, couldn't we? It'd be fun. I mean, this is exciting stuff. Yeah? This is the way you want to spend your morning? Next one. Sylvia. All right, so Sylvia, what's the difference between this one and the previous two?
You have a variable?
Yeah, I have a variable expression inside here, right? So I'm plugging in not a number, but a variable expression. But we're going to follow the same procedure, right? So you would say that we're going to replace all the x's with 2h, yes?
Yeah.
Okay, so how would you like me to write that?
Parentheses.
Mm-hmm.
2h
Squared.
minus 4 parentheses 2h.
Okay.
Minus
Okay, I'm going to ask you to keep going if that's okay. All right. So you put the parentheses here. Super important, especially on this one. Because if you don't put the parentheses like that, what's the difference between these two? So this one's just 2 times h squared, right? But what is this one? It's 2h times 2h, isn't it? And what does that become? Think about that. 2h times 2h. So you multiply the 2's together, you would get 2 times 2 is 4, right? And then h times h is h squared. So this right here becomes 2 times h, which is just 4h squared. In other words, you just square the 2 and square the h. You square them both. Here, you're only squaring the h, so this is wrong. Do you see why it's important? Okay, so Sylvia, this now becomes your 4h squared. And then what's next?
you put the minus 4 with the 2.
Which will give us, so we're multiplying, right?
Yeah. Minus 8.
Minus 8. And then what about that h? It stays, right? So you just get negative 8h, like that. And then minus 5. And notice that this answer is not a number, right? This answer is a variable expression. So this function, if you plug in a variable expression, your answer is going to be a variable expression. Because you don't know what this number is, right? Okay, we good? Sure? All right, let's do another one. This will be the last one. Elena? Wait. Yeah, Elena. Martinez? I screwed it up? No? Okay. All right, so I give you the ugliest one here. Any confusion with that just by looking at it? Is there anything that's thrown you off with it? No? Okay, so what are you supposed to do?
I'll fill it in.
Okay, fill it in. How? This is the original function, right? There it is. Yeah, so remember, we're basing all of our work off of this, right? Everything is based upon this function. If I change this function, all of our answers are going to be different, right? Okay, so equal sign. Okay, can you tell me verbally what I'm about to do?
Fill in the x plus h until next.
Okay, so everywhere I see an x, I'm replacing it with x plus h, right? Okay, so go ahead. Equal sign.
Parentheses x plus h.
Okay, parenthesis x plus h, close parenthesis, square it, okay?
Minus 4.
Minus 4,
Parentheses x plus h.
okay?
Minus 5.
Minus 5, perfect. That's it right there. Now, it's not simplified, but that's correct. So now, let's go ahead and do this, all right? So we have to square this, right? And remember, you do not just square each one. I thought I told you just a second ago that's what we did with the 2h, right? With 2h, when we squared it, didn't I tell you just square each one? And I'm telling you on this one to not square each one, right? Why do I not square each one here, but I do here? This one's multiplication, and that means you can do each one. This is addition. You cannot do each one, all right? This means that over there means we have to do x plus h times itself, and that means we have to FOIL it. Okay, so we have to expand this out, all right? So let me get rid of that thing. So we have to do this times this, this times this, this times this, this times this. And you will get 2x plus xh plus xh plus h squared. I'm going to trust that you can do that because we've done this already, right? And then you can combine these two are like terms because they both have xh in them. Or they're both xh's. So we should get x squared plus 2xh plus h squared. No? I mean, you could do it, right? Okay. So this right here, right, this little ugly thing is just this piece. And then you still have to do what with this negative 4? Distribute it through, right? So you have to distribute that through, distribute that through. All right. So here I go. I'm going to write down first what that is, which is x squared plus 2xh plus h squared. And then when I distribute this through, I get negative 4x. Then distribute again, I get negative 4h. And then finally, I have to add minus 5. Macy? Where's Macy? Macy? So Macy, is there anything I can do with this? I mean, this is this thing with everything expanded out and distributed. Can I do anything with this? Can I collect any like terms, or is that my ugly answer? I'm sorry, I didn't hear you. I didn't know if you said something. That's my ugly answer. Yes, there's nothing I can do with this. There's no like terms, right? I don't have any other x squareds anywhere. I don't have any other things that have both x and h in them. I don't have any h squareds. I don't have just x's anywhere, just h's. I don't have any numbers other than minus 5. So this right here is our answer. It ain't pretty, but it's our answer. Okay. Does this seem somewhat useless? I mean, you could argue that a lot of what we're doing is, but does this kind of seem like, you know, who cares if you can plug x plus h into a function or not? I mean, if I were you and I didn't know what I know, I would probably think this is pretty useless. But I guarantee you that pretty much everything you do in your life relies on somebody having to have done this to a function. Okay, because all of calculus is based upon you being able to plug that into a function or not. I can't get into it here, but you have to just trust me that this to this is vital in all of engineering, mechanical engineering, everything. All right? Driving your car, the fact that the wheels don't come off is all based upon some calculus, and calculus is based upon that. Okay. I think I feel good that if I handed you a function, you could evaluate it at different things. So if I gave you a number, you could plug it in. If I gave you a variable expression, you could plug it in. If I gave you a weird variable expression, you could plug it in. I won't go any worse than this. Okay? I can give you something like that and something like that, but I won't deviate from that too much. All right. Now we're gonna switch gears a little bit and really see if you understand this concept or not. So let's go back and take a look at a line for a second. So recall, let's do this one. 4x plus 2y equals 12. Okay, that is a linear equation, two variables, right? We could graph that, couldn't we? Could we also rewrite it as a function? Could you solve that for y? You could, right? Okay, so let's start with the graph. If I go graph this, this was x, right? And this was y. If I were to be doing this graph, I would do the intercept method. So I would find the x-intercept first. So to find the x-intercept, what do? Set y to 0, right? So if I set y to 0, that's gone. Solve that for x, I get 3. Okay, I'm not going to go through the work, but divide both sides by 4, I get 3. So I have an x-intercept of 3. And I have a y-intercept of 6. 1, 2, 3, 4, 5, 6. And then I draw a line like this. And remember we said that the line is really just all these points, right? All these points. Okay, what was this point again? if I write it as an ordered pair like that, that's 3, 0. So this is the input, that's the output, right? And then here, this is the point 0, 6, so that's the input and that's the output. So the input is always where you are left and right, correct? The input's where you are left and right. The output is always your up and down, right? Yes? Okay, I want to solve this for y. So I moved 4x to the other side. I divided both sides by 2. All right, so I'm not going to go through the steps, but do you believe me that that's what you get if you solve for y? Now what I'm going to do is I'm going to change it to functional notation. Okay, so this is the machine that takes in an x and spits out some value. It's that line, but written as a function. Okay, so I'm going to ask you a question right now. Ready? What is f of 0? Now, don't look at this. You're not allowed to, okay? I'm going to say you can't look at that. I want you to look at that. And I want you to tell me what this is. So it's 6. Who said that? Okay, so can you explain where you're getting 6 from? Like, what's the idea here?
0 is n and then 6 would be.
That's right. This is saying, hey, look, what happens when you put 0 into this function, right? When 0 is the input, it wants to know what the output is. So all you have to do is go and look here and say that it's 6, right? All right. So now let me ask you another question. Where is f of x equal to 0? Christian. I really think, Christian, no? Oh, there you are. Okay. So Christian, did you understand the first problem? This, I gave you, I said the input is 0, right? Tell me what the output is, and we said 6. How is this one different?
The output would be the value of y, while the input would be the value of x at the time. So when y is 0, x would be 3.
Perfect. Okay, so I'll restate what Christian just said. On this one, I'm not giving you the input, right? I'm saying, hey, look, what input gives you this output? So what you're doing is you're going over to the graph. Remember, we're not allowed to look at this right now. We're going over here and we're saying, where is our output 0? And then figuring out what the input was that got us that. Does that make sense? So what's the answer, Christian? 3. Okay. So this would say x must be 3. Okay. Do you all understand what I just did? What we just did? Because now I'm going to draw a picture and we're going to have to answer a bunch of questions. All right, this I just want to start with the line because you're familiar with lines. All right, you might want to take a moment to copy the picture I'm about to put on the board as best you can. And it doesn't have to be perfect. You don't need to break out your colored markers or anything like that. Okay, 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -2, -3. Okay. Now I'm going to draw my function in here. And I think what I'll do is I'll put some very light lines on here so you can tell where things line up. This is not the function. This is just me drawing like a grid on here. You know, I'm realizing now I could have done something else, but oh well, okay. I could have done this because I forgot I had this. I could just turn this into graph paper up here, but oh well, it's done. Okay, you got it? All right, here comes the function. I'm going to put the function up here. That is not a line, right? That is not a line. I have probably the hardest question now of the day, which is going to go to, let's see, who's it going to? Milena. Okay. Milena is going to answer the hardest question of the day. Is this a function? What? Think. Okay. So you said no, it's not. Yes, it is. So, okay, it is. Can you help explain why it is? Now, I haven't talked about this. I've not today given you a picture, so I'm relying on Milena's understanding of this to see if she can justify it. She's saying it is a function. So why?
All I learned is like it's if you like the pencil test, you put your pencil like this way.
You put your pencil like this,
Yeah, and you run it across.
and you run it across.
And if it doesn't touch the same point, then it's.
So if it doesn't touch the same point more than one time, it is a function. Now that is correct. That's called the vertical line test. Okay? So you're basing it on what you've already learned. Good. So you remember that. And that is a test. But I want you to think about it in terms of a machine. Okay? Remember, the x's are the inputs, right? So let me ask you, Milena, if I plug in -1, what does this machine spit out? 2. Does everyone agree? If I plug in -1 into the machine, it spits out 2. In order for it to not be a machine, I would have to have an input go to 2 places, wouldn't I? That would make it not be a machine. So when you look here, is there ever anywhere that you look where there's more than one thing coming out? Like at 2, this comes out, right? Right here, that comes out. Over here, that comes out, right? So if you had 2 things come out, then you would have a dot up here and down here, which is why this test is the test we do, right? Because if I move this across, as long as I'm only hitting one time, that means for every input, there's exactly one output. Does that make sense? So that's what's going on with the test. Good job. Okay, now, here are the questions. I'm not going to ask you that sort of thing on the test. I just want to see if you can make the connection. All right, first one. This is a function. We're going to call this function f, all right? So this purple thing is called f. All right, I'd like to know that. 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 Vince. There you are. Okay. You get the first one, Vince. What is f of -3? Okay. It's too early. 1. Okay, so this is the input, right? So we're going to -3 left and right because that's our x values, right? So we go to -3. That's what you did, Vince? And then what you did is you said, hey, where's the dot, right? And you said you looked at the dot and you looked at the y coordinate, and the y coordinate is 1. Right? So even though it's not written here, this is the point -3, 1. So the first question is saying, hey, if the input's -3, what's the output? It's 1. Okay, so the answer to that one is 1. Any questions? Okay, Alex. Okay, you get number B. You get number B. What is f of -2? So
It's -2, -2 right there. I think that's
is this -2 the input or the output that I'm giving you?
that's the
Input, okay? So the input is the x coordinate. So what you do is you move to -2 on the x-axis. And then you look up and down for your point.
yeah, that's 2.
Okay, so this is the point -2, 2, yes? So the input's -2, the output is 2. So the answer is 2.
I did think moment because of the tick where it was up on
No problem. You got it? Clear? Okay. So Alex is good. All right. And Victoria?
Zero.
0.
X is 0.
Yeah. So at 0, you're just staying here, right? And you're looking for the point. But the point actually is there. It's a little off, but yes. So that point right there is the point 0, 0. 0 goes in, 0 comes out because it's still flat, right? And it's on the y-axis at 0. So that's 0. Good. Stephanie, are you understanding this? These problems, I've always thought that these problems right here are like light bulb problems. Like once you see it, it's like that's it. It's not that hard. But when you don't see it, it's like what's going on? So okay, 0 here. So Stephanie, right? So this is the input or output? Input. So you're going to move over to 2 and look for the output. Where does the output look like it is? -1. Okay, good. -1. So at 2, you come down here to this point. This point is -1. Well, it's a little off, but yeah. Okay? And let's see. Damien? Damien? No Damien? Kristen?
I was wondering if you were going to call me for this one. Okay, so I'm looking at it and I think -1/2, but I don't know if there's a better way to do it.
Yeah, this one is an estimation. Okay, so this one is harder because the way I drew the grid, if you go to 1/2, that means you have to go about right here, right? And then you have to go down and figure out where the point is. I don't know. We could argue about this, about where it is. Where do you think it is?
The OCD in me just wants it to be -1.
-1.
So that it's like
Oh, like right here, you want it to be here?
right in the middle.
I would say that wouldn't be close enough.
So how would I guesstimate that?
I would say, does it look like at 1/2, maybe that's the point right there?
Okay, so then just make it a -1.
-1, yeah. I need to move this up a little bit. There we go, -1. Do you all agree with that? It looks like about halfway, -1. On a test, I'm going to be real flexible on this if I give you something like that because you are estimating. Just try not to be way off. Is that clear for everyone? This should be 1? Sorry, -1? Hey, wait a minute. Hold on a second. Zeke? Two goes to -1, right? 1/2 goes to -1. I thought I said it was a function. Is it a function? I'm trying to trick you, Zeke. Is it okay that 2 and 1/2 go to the same place? Yes, that's okay, right? We just can't have 2 go to 2 different places, right? So just because this happens, we get the same answer. That's okay, right? It's okay. All right, so these were the easy ones. Let me go with the harder ones. So part E. Where is f of x equal to 0? Let's start with that one. We'll just go one at a time here. Okay, Devin, right? What's different here, Devin? What's different between part E and parts A through D?
You have the x and then you have this other number.
Okay, so like here I gave you the x, right, and asked you for the y. Here I'm giving you the y and asking you for the x. So I'm asking you, for what value of x do you plug in and get a y value of of 0? So at 0, right here? Is that what you're saying? Do you all agree with that? The x that would spit out a 0 happens right here. Agreed? Okay, is that the only answer, Devin? Is there anywhere else where your y value is 0 on this graph? So here your y value is 0, right? Right here, because your up and down is 0. What about right there?
So 0.
This is also 0, right? The y value is 0, but at what x value does it happen? Because remember, this is giving you the y value, right? This is your y value. And what you're being asked for is what's the x value that goes with it. You said 0. I agree. X equals 0 is an answer. If I plug 0 into this function, it spits out 0. But that's not the only x that I could plug in. What other x can I plug in? So I don't think you're making the connection.
Yeah.
Okay. This right here, this being 0 is because if I plug 0 into the function, it spits out 0. That point lives on the graph, right? That's that point. What's this point written as an ordered pair?
0, 3.
0, 3. So what's your input?
0.
Okay, I'm sorry, that's backwards. You said 0, 3, I wrote it down. That's 3, 0, isn't it? 3, 0. So what's your output?
0.
And what was the input?
3.
3. Here, the point is 0, 0. What's your output?
0.
What's your input?
0.
Okay, so this is saying, hey, when is your output 0? And you realize there's two places where your output's 0. It happens at 0 and at 3. Does that make more sense now?
Yeah.
This is a chance for everyone to ask a question here. Given the y value, can you tell me what x values it comes from? There are two x values that spit out 0. Let's do another one. Where is f of x equal to, well, let's go with this one, okay? Keep it kind of reasonable at this point. Josh? Where's Josh? Josh?
Yes.
You awake?
Yeah.
Yeah? Okay. Everyone's like, man, it's too early. Remember, you signed up 9:30, and I did too. Okay, so I'm giving you the y value, and I'm asking you what x values would spit out this y value. Okay? So can you see where that would happen? Where on your graph do you have y values of -1? Right here, right? At 1/2? Anywhere else? Do you have another y value of -1 anywhere? So just look left and right. You have this one, right? There's nothing over here, right? There's no graph over here. How about over here? Right there, right? You have two different places where you have the y value of -1. You said 1/2, and where's the other one?
2.
At 2. Okay, so your two answers here are x equals 1/2 and 2. Okay, are we always going to have two answers? Let's see. Part G. Where is f of x equal to -2? Heidi? Where's Heidi? That's you? Okay. Is it making sense to you, what we've been doing? Kind of?
Would it be F1?
At 1, good. Okay, at 1. So what Heidi's doing, she's looking, where's my y value, -2? So she's going down to -2, right? -2, y value, -2. And she's looking for a point on the graph. And here it is, right? And then she's going back up and figuring out the x coordinate it came from. Heidi, is this the only place your function is -2 that you can tell? Is there anywhere over here that we have a dot or part of our graph? Is there anywhere over there where we have graph? No, right? So that's the only place it happens. So we only have one answer here. 1. Last one. Ready? This is the last one we're going to do. Any questions? These normally students kind of like, okay, I can handle that. This is where students have trouble with these. Okay, where is the function's value 2? Who's the unlucky one here? Pick one, Vince. Who's unlucky? Kayleen. Where's Kayleen? Okay. Did you get your spot today? You didn't?
This is hard to do.
Ah. Okay. Kayleen, you get the hardest one. And I'm not necessarily even going to expect that you can get this, but maybe you can talk through what's confusing about it, if it's confusing you.
There's no point where y is 2.
Where y is 2, what do you mean there's no point? Y value of 2,
Oh, wait,
there is.
So would it be x equals negative 2 and negative 1?
-2 and -1, what do y'all think? Does that seem reasonable? At -2, does it spit out 2? Yes. At -1, does it spit out 2? Yes, I agree. But there's more. Just look at the graph. Remember, what does the line really mean? That those are a bunch of points, right? So doesn't that mean that, like, if I plug in this number, it's going to spit out 2 also? And if I plug in this number, it's going to spit out? So it's not only just -2 and -1, it's everything in between it too, right? Everything in between it. So how do we do that? We can't sit here and say, you can't be like x is -2, -1, and then start listing out all the numbers between here and here, right? You can't. There's an infinite number of numbers in here. So what we do instead is we don't list them out like this. We write it in what we call interval notation. So we say something like this. X is in the interval -2 to -1, using brackets. And that's saying as long as x is in here, the output's going to be 2. Do y'all agree with that statement? If you pick any x between here and here, then the output's going to be 2. You could also write it this way. X between -2 and -1. If that makes more sense, if you've seen that notation, x has to be bigger than or equal to -2 and less than or equal to -1. But this is an infinite number of answers, as opposed to, like the previous one, we had one answer, and the previous to that we had 2. Yes?
Right, so that would be like f of bracket, like 2?
F of bracket?
Like is he saying brackets?
This is what's called interval notation. I'm going to have to explain a little bit better if that's confusing. Can we be done with this? I'm going to erase it. Okay, so the idea is this. Just kind of forget everything we've been talking about with functions right now. Let's just talk about a number line. Okay? If you look at a number line, right? If I tell you, hey, look, see that number right there, number 1? Let's say I want to let you know that that's the answer to something. I would just write x equals 1. All right? If I said, hey, it's x is equal to 1 and 2, then I could just write x is equal to 1, comma 2. Right? But if I want to include all the points in here, everything, all those points, then I cannot use this notation anymore because you can't list out all the numbers between 1 and 2. Right? What numbers are in here? 1.5, 1.4, 1.3, 1.2, 1.1, 1.11, 1.1111. There's infinitely many. So we can't use this notation. So what we do is we say, all right, if we want to talk about everything between 1 and 2, what we'll do is we'll write a bracket, we'll put a 1, we'll put a comma, we'll put a 2, we'll close a bracket. And that lets everyone know everything between 1 and 2.
So saying we can just don't put the f.
The f has nothing to do with this. Yeah. Yeah. Yes.
So, okay, so you know how we did like for b
Uh-huh.
is with the -2? We can't go off base of that? Like if it's giving you the 2.
Yeah, so I'm glad you caught that. The question is, see on this one, we said where is f of x 2? We could have come back here and we would have said, hey, look, -2, right? Got sent to 2. But the problem with that is that this told us to just look right at -2 and see what the output was, right? This is asking us to look at all the outputs that are equal to -2, and there could be more than one. And in this case, there's an infinite number of them. So if you were to just go backwards from this, you wouldn't have the correct answer. Very good question. Okay. Well, I've got this